Alright, good afternoon. So, triple one, we are going to continue with trigonometry, right? Alright, so basically speaking, so MSM triple one. Okay. We ended on question 8, right, where we ended on question 8 where we were asked to find tan alpha, and we were asked to find tan alpha minus beta, right? So now we're going to go to question 9, right, and we'll do one of them. Okay, we'll do both of them on question 9. Okay, so question 9a says find the exact values without using a calculator or a table. So cos of tan inverse of 7/24 minus sine inverse of 4/5. Okay, so you've been given that question there. How do you go about it? Okay, so basically speaking, this concept is not so different from the ones that we're just from doing. They're not so different from the ones that we're just from doing. Okay, so how you deal with such a question is we're first going to look at where is tan inverse of 7/24, right? So I'll write this first. We know that x, let's say x is equal to tan inverse of 7/24. Meaning that tan x is actually 7/24. Alright, this is how we basically do that. Right, so that's how we deal with such questions. Right, so the inverse here simply means that we're dividing both sides by tan. Okay, so if I was to multiply both sides by tan, you notice that this is tan x is equal to 7/24. Alright, so this inverse means that the tan was here, we divided both sides by tan, that's what we have an inverse. Right, so tan inverse of 7/24. Okay, so tan x is equal to 7/24. That's what we have. Then the other part which we have now is, let's say x is equal to sine inverse of 4/5. Then what is sine x? So sine x is 4/5, right? So sine x is 4/5, and tan x is 7/24, right? That is that. Okay. All right. So let's put our solutions here. So we're saying tan x is 7/24, and sine x is equal to 4/5, right? Now we're going to make reference to the identities that we have. So we need the cos identity. If we're going to use the trigonometric identities, we want to write what cos is. So by use of the trigonometric identities, what is cos? Alright? Okay, so let's say cos A minus B. According to the trig identity given, this is going to be cos A, cos B, plus sine A, sine B, right? So that is going to be cos A cos B plus sine A sine B, all right? So cos A cos B plus sine A sine B, right? So this is basically what we get at the end of it all. Now we know that we can replace that with the actual ones which we have. So in this case, A is this, cos A is this. We also know what cos B is. We also know what the other one is. All right. So this is the same as saying this can be written as tan cos of tan inverse of 7 over 24, all right? Then cos B in this case is sine inverse of 4 over 45 over 5, 4 over 5, okay? Then plus the sine part, we have sine A, which is sine tan inverse of 7 over 24. Then sine B, sine of sine inverse of 4 over 5. Okay. Alright, so if you are going to compare these, let's say A is cos to this part, right? Then you will notice that okay, so let's say A, yeah, so let's say A here is cos to tan inverse of 7, so tan inverse of 7 over 24, all right? If A is cos to 7 or negative 7 over 24, then you have tan A, okay, as tan A will basically be 7 over 24, all right? So this is what your tan A is. Now that we know what tan is, but we also have been told by SOHCAHTOA, if you use SOHCAHTOA, that tan is actually opposite over adjacent, all right? So we've been told that that is opposite over adjacent. So we can find, so we notice that this one is positive, right? Notice that this one is positive, meaning that the other ones also can also be concluded to be positive. If it was negative, we'd actually assume that that is negative. So if we have those two as our values for tan, so this is basically an opposite and this is the adjacent part, okay? So we are looking for tan inverse. We are looking for, yes, so we're looking for, we've been told that tan A is 7 over 24, right? So tan A is 7 over 24. What is going to be cos of A? Remember, I've said that this part now is being represented by tan. So what is cos A? All right, so what is cos A? So if A is given as tan inverse of 7 over 24, what is cos A? Right, so I'm basically doing a comparison between the two, okay? So cos A, in this case, we know that tan A is 7 over 24. What is cos A? So cos of A is simply going to be, remember that we know cos is given as adjacent over hypotenuse, right? Then what you will notice is that we do not really have, from the tan A here, tan A is given as opposite over adjacent from the OR, okay? And we know that this is 7 and this is 24. Okay, so basically speaking, you have the opposite as 7 and the adjacent as 24. So what is the hypotenuse in that case? Okay, so the hypotenuse in this case will be 7 squared plus 24 squared, right? So we have hypotenuse squared is equals to 7 times 7 is 49, right? Then 24 plus 24. Okay, so we're saying 24 by 24 is 576, right? So plus 576 by 576. Then we take the root on both sides. So we have the hypotenuse is therefore equals to the root of 49 plus 576, so plus 49, 625. So we're looking for the root of 625. Okay, so what is the root of 625? So that's basically what we are looking for. Okay, so the root of 625 is 25, right? So meaning this is actually 25. So that's basically going to be 25 as the hypotenuse. Now that we know what our hypotenuse is, what is cos theta? So cos A is now basically equal to, cos A is equal to adjacent. Adjacent has been given as 24, hypotenuse has been given as 25. Okay, so cos A is 25, okay, 24 over 25. So now we want to know what is cos B. Okay, let's also find sine A. Alright, let's also find sine A. So that's 24 over 25. Now the next thing is we want to find sine A. So what we said is, whenever you're dealing with such a question, right? So we use the property of the inverse. Okay, so the property of the inverse is I distributed first by the identity rule. So we use this as identity cos A cos B plus sine A sine B. That's the identity in question. So now we've been told that we are looking for cos of tan inverse of 7 over 24, cos of sine inverse of 4 over 5. All right. So how do we find that? Then plus sine tan inverse of 7 over 4, sine over sine inverse of 4 over 5. All right. So now, assuming that you actually equate these two, you will notice that A is tan inverse of 7 over 24. All right. So A is tan inverse of 7 over 24, and we have A is equal to tan inverse of 7 over 24. So what is tan A? Tan A is 7 over 24. Right? So tan A is basically 7 over 24. Now tan A is 7 over 24, but that's not what we're looking for, right? We've been asked to find what cos A minus B is. So cos A is therefore we need to know what is the adjacent and what is the hypotenuse, given that tan A is 7 over 24, with reference to the previous questions that we were dealing with the last time. So if you remember the way we were dealing with the last questions, we'd actually find maybe tan, then we were asked to find the other trigonometric ratio. So this is a build-up on that, and now we are applying it to a different question, okay? Something that is similar to it, but just similar, okay? So we now found tan A at 7 over 24, but if you follow tan is actually opposite over adjacent. So 7 is the opposite and A is the adjacent, right? So we are missing the hypotenuse, right? So we want to find cos A, but we cannot because the hypotenuse is missing. We know what the adjacent side is. The adjacent has been given as 24, but we now need to know what is the hypotenuse. So we use the Pythagoras theorem So by Pythagorean theorem, what we get is hypotenuse squared is equals to 7 squared plus 24 squared, and then from there what you now get is, so from there what you're now going to get is, you'll notice that hypotenuse squared is equals to 49 plus 576, which is root of that is 25. So now that we know that the hypotenuse is 25, we're going to use this 25 as the hypotenuse to find cos A. So cos A is 24 over 25, right? So cos A is 24 over 25. So now, since we are still dealing with A, let's also find what sine A is, right? So we found cos, let's find sine A. Okay, so how do we find sine A? We know that sine A is going to be opposite over hypotenuse, right? So we're saying sine A is opposite over hypotenuse. But we've been told, or we found the opposite, the opposite was given from the tan part as 7, the hypotenuse is 25. So this is what sine A is. Okay, sine A is 7 over 25. So that is what sine A is, 7 over 25. Seven over 25, that is what your sine A is. Next up, we want to now find the B part. We now need to find the B part. So I'll basically write those values or the answers somewhere so that we can make reference to them at the end of it all. Okay, so I want to make reference at the end of it all. So I'll erase this part. Okay, so remember that we have we're comparing, all right? We were comparing, so we noticed that sine B, tan B actually, tan B was given as make reference back to the question. Okay, so the other part which we're told is that sine inverse is 4 over 5. Okay, so sine inverse is 4 over 5. Sine inverse is 4 over 5. So from there we noted that sine x is actually 4 over 5. Alright, so as we said, we have cos A minus B being equals to cos A cos B plus sin A sin B. Okay, then we said the cos part is equal. So now we have cos B is equal to cos of sine inverse of 4 over 5. Okay, so meaning B is actually equal to sine inverse of 4 over 5. Right, so what is sine B? So sine B is 4 over 5. Okay, so if we know what sine B is, Remember, we find sine A as 7 over 25, and we found cos A as 24 over 25. So let's take note. So cos A is 24 over 25, and sine A is 7 over 25. So now we have found sine B as 4 over 5. We now need cos B. Okay, we now need cos B. Cos B okay, so cos B will basically be equals to, so what is what is sine B? Sine B is 4 over 5. So we know that cos is found as adjacent over hypotenuse, right? But what we've been given is sine B. And sine B is 4 over 5. Sine B is opposite over hypotenuse, so meaning the opposite is 4 and the hypotenuse is 5. So we have the adjacent part missing from this. So we can find it. Hypotenuse squared is equals to adjacent squared plus opposite squared. Right? So we can find it using that formula. From there, we actually can now derive. From there, we can derive hypotenuse squared. Hypotenuse was already given as 5, so 5 squared is equals to adjacent is what we're looking for, plus opposite. Opposite has been given, yes, as 4 squared, right? So we have 25 minus 16 is equals to adjacent squared. Okay. All right. Then from this, we are going to find that adjacent squared is actually equals to root of 25, root of 9. Okay. Which is basically 3. So we've now found the other side as 3. So adjacent is 3. Adjacent is 3. So now that we know that adjacent is 3, the opposite was given as 4 and the hypotenuse was given as 5. Alright, let's find the cos. So cos of B is actually 3 over 5. Okay, so cos B is 3 over 5. Then getting to the answer, cos A minus B is therefore equal to cos A. We found that's 24 over 25, so cos A is 24 over 25 multiplied by cos B, which is 3 over 5, and then plus sine A. Sine A, we found sine A as 7 over 25. Then we found sine B. Sine B was 4 over 5.
is the lesson going on up to
15.
15. Oh.
Okay, so next up, okay, this is not so visible. So we're saying this is cos A was 24 over 25. Cos B, we found cos B as 3 over 5 plus sine A as 7 over 25 and sine B as 4 over 5. Okay, so that is what we found. That is what we found. Okay, so from there, we can actually find what the actual values are. So 25 by 3, 24 by 3 is 72. Okay, so we have 72. Over 125, okay, plus 21 over 125. Okay, so this basically ends up being 125, then 93 over 125. So that is the answer, 93 over 125. Okay, that is the answer. Next. Right, I think basically now that we've shown you how to go about these questions, I think the rest should be similar. So, how do you find the sine tan inverse of 3 over 4? Let me write the question, then we can make reference to it. Okay, so what I will do is, based on the information that we did, okay, so sine A minus B is equal to This is sine A cos B minus sine cos A. Okay, so basically speaking, this is what we have. I think now it's more direct than before. So basically speaking, we have this as A and this as B. Okay, so if you compare these two, you have A is equals to tan inverse of 3 over 4. Okay, and then we have B is equals to cos inverse of 24 over 25. Alright, then from here you can actually find tan A. Tan A is now going to be given as, alright, so in the next 2 minutes, find tan A and find tan B. So if you are watching, the next 2 minutes find tan A, and you can write the expression for tan A. You can also write the expression for cos A, cos B. Okay? So basically, that is how you are going to go about it. Okay.
Yeah.
Okay, so tan A, tan B. If you've been checking or if you've been following, let me write this. So we're basically saying, if you look at this one here and this one here, A is actually this and B is that. Okay, so that's what you have in that question. So if you're comparing these two, A is tan inverse of 3 over 4 and B is cos inverse of that. So this is why we have this being written as A is actually equals to tan inverse of 3 over 4 and, okay, B, in this case, B is cos inverse of 24 over 25, right? So meaning A, tan A can be written as 3 over 4 and cos B can be written as 24 over 25. Okay, so that is that. So from there now we're going to find the trigonometric ratios. Now look at this, you're looking for sine A, which we don't have, but we have tan A, right? Now we know that tan is opposite over adjacent, right? And this has been given as 3 over 4, right? So meaning that opposite is 3 and adjacent is 4. What is missing? The hypotenuse. So we know that height squared is equals to adjacent squared plus opposite squared. Okay, this actually ends up being adjacent is 3 is 4 squared plus 3 squared as the hypotenuse. We're looking for h. So h squared is equals to 16 plus 9. H squared is equals to 25. Root, so h is equals to 5. So that is basically what you have as the value for h, right? That's how you go about these things. All right, so hypotenuse is 5. So now that we know that the hypotenuse is 5, we need to find the missing link, okay? So the missing value is, we now need sine A, okay? Sine A is opposite over hypotenuse, all right? Sine A is opposite over hypotenuse. So therefore, sine A ends up being opposite has been given as 3 and hypotenuse has been found as 5. So the answer is 3 over 5, alright? So we're saying from here sine A is 3 . Okay, but that we found that the next thing that we need to now find is we want to find out what the missing one is. Well, what we have, we need cos A. We need cos A. So for us to find cos A, let me write the ones we have here. So sine A has been found as 3 over 5. We need cos A. Cos A is found as adjacent over hypotenuse. So now, adjacent over hypotenuse, remember the angle is A we're dealing with, so it's like you're in the same triangle, okay? It's like you're in the same triangle. So the triangle here has got the theta as A, okay? So the angle is A. So this is why you make me, you notice that I'm getting back to the same values. So the hypotenuse for sine A, for the tan A, okay? So meaning that this angle A is the same angle for sine, is the same angle for cos, okay? But remember that the ratios end up giving us different values, all right? So this is why my reference is different. Okay, so we have tan A is equal to 3 over 4. So meaning that what is cos A? Adjacent was given as 4 from tan. The adjacent, because it's opposite over adjacent, so adjacent is 4, hypotenuse is found this as 5. Okay, the next part is we now need to find B on the B. So if the angle we're dealing with is now B, if the angle in question is B, how do we get to the answer? If the angle we're now dealing with is B, how do we get to the answer? All right, so okay, so in this case we know that cos B is 24 over 25, which is actually basically more straightforward. So here we have cos B being equals to 24 over 25, okay? So this one has been made straight for us. So cos b is 24 over 25. But now we don't know what sine. This is cos A, cos B. So this should be sine B. Okay, so sine A cos B minus cos A sine B. All right, so take note of that. Such changes. Okay, so this should be sine B. So we now need sine B. Right, so cos A cos B. So we found sine A. 3 over 5, we found cos B, 24 over 5 from this, okay, then, then the other thing that we have is, we now have to make, we are doing comparisons, right, with the angle B, meaning that I could have written this cos is still adjacent over hypotenuse, right, and this is 24 over 25. Okay, so it's 24 over 25. What do we then have as our angle in question? What is sine? Sine is opposite over hypotenuse. So we have the adjacent and we have the hypotenuse, but we don't know what the opposite is. So we need to calculate for the opposite, ladies and gentlemen. We need to calculate for the opposite. How do we do that? So in calculating for the opposite, we know that opposite squared. Okay, let's continue using the hypotenuse, the actual theorem. So let's just say hypotenuse squared is equals to adjacent squared plus opposite squared, right? Hypotenuse is what we have as 25 squared. Adjacent is given as 24, okay, squared, and what is missing is the opposite. Alright, so this is for the sine of for theta being equals to b. Okay, for theta being equals to b. We have 25 times 25. Alright, let's look at what that gives us. 25 minus 25. Okay, so 25 by 25 is 625. So we have 625 minus 24 times 24. 576, and this is equals to opposite squared. Right, so meaning opposite squared is equals to 625. 625 minus 576, right? So which is 49. Root there, the opposite now becomes 7, right? So when you have a triangle B with the theta being equals to B, the opposite is 7, right? The opposite is 7. Now, ladies and gentlemen, one of the things that we will usually note, right? One of the things that we usually note is when you are finding this, so the opposite is 7, right? What will then our sine be? Remember, that's what we are looking for. We are looking for sine B. So sine B is opposite over hypotenuse. Opposite is 7, hypotenuse is 25. Okay, so that is basically that. Okay. All right, so we have sine A, cos B, sine B. So we're saying cos of A minus B. No, actually, we're not looking for cos. Alright, so we're looking, the question is sine A minus B. I've replaced that. I've already replaced. So tan inverse of 3 over 4 is now A, and tan, and the other one is given as that, right? Now the identity for sine, the identity for sine, we say the sine A, cos B. Since it's minus, it maintains as minus cos A sine B, right? Cos A sine B. Right, so now we know what sine A is. We found as 3 over 5 multiplied by cos B as 24 over 25 minus cos A as 4 over 5 multiplied by sine B, which we found as 7 over 25. Alright, so from this we have 24 by 3, we have 72. Now remember that the denominator is almost this, it's actually exactly as the last one, which we did 125, right? So 125 minus the numerator, 4 times 7 is 28, so we have 28 over 125. So this is basically 125, then 72 minus 28 is what we are looking for, okay? So which is 44. So the final answer ends up being 44 over 125. Alright, so that is the answer that we get. Alright, so this is how you go about those questions. Okay, so whenever you are given such a question, make reference to compare. First write the standard formula which you have, then compare the standard formula with what you are given. Alright, so this is how you go about that question. Okay, so right, so if you write this as sine, if you write that as sine, with reference to the question, huh? So we have sine tan inverse of 3 over 4 minus cos inverse of 24 over 25, right? So if you look at these two, right, so you say from here A is actually tan inverse of 3 over 4, okay, and B is actually cos inverse of 24 over 25. So from this we said, from this is where we now ended up having tan A is equals to 13 over 4 and cos B is equals to 24 over 25, right? Now if you look at this, the angle tan with an angle A is 13 over 4. So this is the opposite, this is the adjacent. So we can actually find the other identities. We can find cos A and we can find sine A from this, okay? Here we can also use this cos B. Fortunately, has been given for us, but we can use sine B. We can find sine using this, but since this is 24 over 25, meaning this is the adjacent and this is the hypotenuse, so the opposite is missing. So by the Pythagorean theorem, by the Pythagoras theorem, this is how we get to find the opposite side. So the opposite side we found as hypotenuse is equals to opposite plus adjacent. So hypotenuse minus the given side. So in this case, we were given the adjacent. So hypotenuse squared minus adjacent side is what gave us that. Okay, so that we could find sine easily. Then after that, we found the values. Right. So we're saying this is the standard way of doing things. Okay, that's the standard way of doing things. Lastly, question 10. Okay, so we've been told, prove that sine x plus 90 degrees is actually equals to cos x, right? So we're going to make reference to this. So meaning sine x plus 90 degrees is actually equals to sine x. Okay, sine x cos 90 degrees plus cos x sine 90 degrees, right? So we know that cos is actually, cos 90 is 0, so this is 0. We know that sine 90 is 1, so this ends up being sine x multiplied by 0 plus cos x multiplied by 1. Okay, so which ends up as being cos x. So I've used the sum difference identity in order for me to identify or get to my final answer. Right, so that's how we deal with such questions. It's basically not as complicated as they look. All right. All right, so just a simple one. Then we mark the end of the tutorial. You have cos. Prove that cos y plus 90 degrees is actually equals to negative sine x. Right? Negative sine x. Now we know that the identity for cos of a plus b is actually equals to cos a, cos b. Since it's plus, it's minus sine a, sine b. Alright? We know that cos a, in this case, is, so we have cos of y plus 90 degrees. This is going to be cos y cos 90, all right, minus sine y sine 90, all right. Then we know that cos of 90 is 0, so this is cos y, 0 minus sine y multiplied by sine 90 degrees will give us a 1, so this ends up being negative sine y, right? So again, I've applied the identity for cos, the sum difference identity for cos in order for me to derive that, right? So ladies and gentlemen, as I said, if you've not subscribed, please subscribe, right? So subscribe to the channel. This marks the end of our tutorial. This is basically how you go about those questions, right? So see you next time.
Ah,